Hello everyone, good morning. My name is Agnes Arnold. I am anesthetic technician at Rotorua Hospital. I've been trained as an anesthetic assistant for best part of 20 years, and I've got some background in theatre and recovery nursing as well, as a registered nurse. So today I'm going to do very much a review of our first lecture that we held in Suva a year ago during our Pacific Anesthetic Assistance course. So it will be very much a revision of the material for those who have attended that lecture. And a lot of the material covered is pretty general and basic stuff that we just need to go through in one of our early lectures of the online program to make sure that we're on the same page with terminology and the background information that we need to go forward from here. So the learning objectives for today are going to be the overview of the upper airway anatomy and physiology, and we will also be looking at some of the most basic airway devices that we use in our day-to-day practice, and we will be looking at the understanding of the terms subglottic and supraglottic. So airway physiology, and excuse me my coffee, but I am not currently in Suva, and so it is pretty cold here, so hence my hat, hoodie and a hot drink. Okay, just trying to keep myself from freezing at the moment. This is a New Zealand springtime after all. So airway physiology. Why have we got an airway? So we all know that we're surrounded with gas or atmosphere that we call the air, and the air contains 21% oxygen. We also know that our body, every single cell or the building block of our body requires oxygen in order to survive. And the reason for that is that oxygen is a necessary ingredient for energy production. Without oxygen, the cells in our body cannot survive very long. We're talking a matter of minutes for most of them. And so oxygen is crucial. And that's where the airway comes in. So airway is the system that allows us to move the oxygen from all around us into our body and into our circulation or our blood, and it can then be distributed to all the parts and all the cells. I'm just doing a recording, sorry, of our body. And so yes, so this oxygen gets transported through our airways, and that's the system that we need. So the system consists of the upper airway and lower airway. The upper airway is very much just the tube, the transport tube, and the lower airway is the lung and the function that actually absorption of the oxygen and its movement into the circulation, which can then transport it around the body, occurs. So the additional airway functions, so is the delivery of oxygen the only function the airway performs? No, there's plenty others. It also helps us get rid of the carbon dioxide, which is what we breathe out, and carbon dioxide is the byproduct of energy production in the cells of our body, and that when built up can be quite damaging. So we need to keep getting rid of it continuously, and that's where the airways come in. It also helps us filtrate the air. It helps us smell and taste things. It's got warming and humidification function. It provides all sorts of protective reflexes such as sneezing, coughing, laryngeal closure reflexes, gagging reflex, but also speech, swallowing, and immune function. The airway anatomy, like already mentioned, it can be divided into upper and lower. The upper airway consists of nose, and the space behind it, which is called nasopharynx, mouth, and the space behind it, which is the oropharynx. And that's how the air enters our body through the atmosphere as a first line. But then the two, oral and nasopharynx, merge into the pharynx or the throat. And then further down, we've got the larynx or the voice box, and then the lower airways, which consists of our windpipe and bronchial tree, which are transport tube, and our lungs, which is the gas exchange organ. Hi, so welcome back. So I'm recording this lecture in stages. So this is because due to time constraints, so please accept my apologies for the fragmented nature of this video. I am here back with another cup of coffee. So just going back to our slide that we went through last, this is the basic upper and lower airway anatomy, and as described verbally. But we can look at the picture now, and this is photo from our first airway lecture that we did in Suva last year in 2019, and I love this photo on so many levels. But what I want you to have a look at, let me just get my spotlight here. Yeah, it's this drawing here because I didn't have access to airway materials online when we were in Suva. I was resorting to drawing my own photo, my own pictures, and this is a picture of upper airway. So you'll all be very pleased to know that we have professional pictures now, which are actually anatomically accurate. So that should really aid our learning, luckily. So you don't have to suffer my drawings anymore. So in this photo, we can see the anatomy that we have discussed in the previous slide. So we've got nose or the nasal cavity right up here, and the space behind it, which is our nasopharynx. Then we've got the oral cavity or the mouth, and behind it we've got the space which is called oropharynx, and they all both merge together into the throat or the pharynx. Now from the pharynx, the air that we inhale moves down through our larynx and down into our trachea. And we can look at our larynx here. We've got it divided into several parts, but the one that I really want us to focus on is the term glottis. So let's move to the left of our slide here. So larynx is also known as the voice box, as part of the upper airway, which contains the vocal cords. And the vocal cords are the two muscle flaps, smooth muscle flaps, which open and close as we allowing us to produce our voice. But they also have other functions, the reflex function of closing and protecting our airway from aspiration. Aspiration being inhalation of things of other than air, such as gastric contents or secretions of fluids. So they stop us from aspiration. And the term glottis is reserved for the opening between the vocal cords. So the glottis is a very important part of our airway, and it has got many functions, and voice production and protection of the lower airway from aspiration being two of them. So the term glottis is important for us because from that particular place in our airway, the terminology for some of the airway devices is derived. So we have got additional terms here on the left. Supra means above, hence the term supraglottic means above the glottis. So supraglottic means any part of the airway above the glottis. So anything that sits in the nose, anything that sits in the mouth is our supraglottic airway. Sub means below, subway, submarine, etc., etc. So subglottic means below the glottis or below the vocal cords. So our subglottic airways will be the ones that are going to cross the glottis or go through the vocal cords and go down into the lower airway, into the trachea. So these terms are quite important, and so far that they describe the types of airways that we use and how much protection against aspiration they offer. Another interesting related term is epi. So epi means near. For example, epidural means near the dura. And epiglottis is cartilage flap. It is attached at the front and sits above the glottis. So the epiglottis has got a function, additional function of protecting our airway. It bends backwards to occlude the airway when we swallow. So as we see, after our pharynx, the esophagus and the pharynx splits into the esophageal tube and into the tracheal tube. And so in this particular danger spot, the gastrointestinal system in the form of a gullet and our respiratory system here in the form of a larynx and a trachea are very close to each other. And the food and the fluids that come in through our mouth have gone down to our stomach, or that are coming back from our stomach because we are regurgitating or vomiting, they pose a real risk of potentially going down into the trachea, because all of this is so close to each other here as the airway and the gastrointestinal canals cross at this point. And so the function of the epiglottis is to occlude the opening of our airway when we swallow. So when we swallow saliva or when we swallow food or drink, this cartilage flap bends backwards and occludes the glottis. So this is the additional protection of our airway on top of the glottic opening and closing, which also protects us from aspiration. Epiglottis has a similar function during the swallowing, and it is therefore a very important and interesting part of the airway anatomy and physiology that's worth mentioning. So moving on to the next slide. Why do we maintain the airway under anesthesia? So the reflexes that we've described before, protective airway reflexes such as the glottic closure and such as the opening and closing of the epiglottis, which protect us from aspiration when we're awake, they get knocked out by the anesthetics. And so when we are under general anesthesia, these reflexes no longer function. Additionally, we've got structural issues with our airway, which mean that it is not a very solid tube. It is quite a soft, easily collapsible tube. For instance, apart from our hard palate, our roof of the mouth, or parts of our nasal cavity, Majority of the airway is soft and very easily collapsible. It's not exactly as soft as a sock, or for instance. It has got a little bit more of cartilage and some structure to it, but overall it is very easily collapsible. There's no bones keeping it open. It's not really that that strong. So so how come it stays open? We all know our airway devices here. If we look at my video screen now, laryngeal mask airway, endotracheal tube. We all know that we routinely use them during anesthesia. How come I don't need them when I'm sitting right here when I'm awake? You know, do I need this to be put into my throat to keep my airway open? No. Despite the softness and the normal squashiness of the airway, we manage to maintain our airways open perfectly well when we're awake. And that is because our pharyngeal muscles actively dilate and expand the airway. So we've got quite a few, like 9 or 10 pharyngeal muscles, which do nothing else but focus all the time whilst we're conscious and awake to keep dilating or expanding, pulling the airway open all the time. So general anesthesia, however, reduces the brain function, and with the brain function, it reduces the nerve transmission and knocking out the signals which the brain normally keeps sending to those muscles to keep dilating or expanding our airway, and the airway becomes soft and collapsible even more. Therefore, and also because we've lost the epiglottis and glottis function and the other protective reflexes under anesthesia, such as coughing, gagging, etc., which normally additionally protect our airway, the collapsibility of the airway and the increased risk of aspiration that come with the general anesthesia mean that occasionally we require to use these devices and some others that we go through in a minute to protect and keep the airway open and keep it safe when the patient is unconscious under general anesthesia. Yeah, so now we're going to look, so excuse me for the interruption, now we're going to look at some of the anesthetic airway devices, and hopefully they're going to make a little more sense in the terminology that we use. Because of this explanation. So the external devices, let me see if I can get my spotlight back. Yeah, so the external devices are the ones that are on the outside of the airway. So they're not non-invasive. They just sit on top of the outer airway openings. So we could have a face mask, a nasal mask, or various forms of nasal oxygen delivery. We've also got internal devices, and the internal devices are the ones that are invasive. They go inside our body. And the internal devices are divided into supraglottic and subglottic. So the supraglottic devices we've already discussed are the ones that are going to sit above our glottis, and the subglottic devices are the ones that go through the glottis and into the trachea and towards the lower airway, and they are called subglottic. Supraglottic devices, and these are just examples. You know, I want to make it clear that this list that I've covered in this entire slide of all those airway devices by no means exclusive. this is just examples to give us an idea, a general idea of the classification of the most common devices that we use in our daily practice. So the supraglottic, the ones that do not go through the vocal cords but sit above the vocal cord, are the oropharyngeal airways, nasopharyngeal airways, and the laryngeal mask airways, or the LMA. And the subglottic devices are basically just endotracheal tubes in all their shapes or forms. Or we could also have tracheal tubes. They are more ICU used, the ones that will go directly through our neck into our trachea without going through the vocal cords. But we won't focus on this in this lecture.